Hello, welcome to the next section of the course, Arrays and Lists. This section will focus on the arrays that will be presented and divided into single-dimensional, multi-dimensional and jagged arrays. We will also get to know 4 sorting algorithms, namely selection, insertion, bubble sort and quicksort. Let's start with the first video that deals with arrays. Let's start with the array data structure. You can use it to store many variables of the same type, such as int, string, or a user-defined class. As mentioned in the introduction, while developing applications in the C# language, you can benefit from a few variants of arrays, as presented in this diagram. You have access not only to single-dimensional arrays, but also multidimensional and jagged. Examples of all of them are shown in this diagram. Let's proceed to the simplest variant of arrays, namely single-dimensional ones. A single-dimensional array stores a collection of items of the same type, which are accessible by an index. It is important to remember that indices of arrays in C# are zero-based. This means that the first element has an index equal to 0, while the last one, length of array -1. The example array is shown in the preceding diagram, on the left indicated by A. It contains 5 elements with values such as 9, -11, 6, -12 and 1. The first element has an index equal to 0, while the last one has an index equal to 4. To use a single-dimensional array, you need to declare and initialize it. The declaration is very simple, because you just need to specify a type of element and a name, so let's enter the code. Then the declaration of an array with integer values is done using int method. Now, you know how to declare an array, but what about the initialization? To initialize the array elements to default values, you can use the new operator, as shown here. Of course, you can combine a declaration and initialization in the same line, as the code shown here. Unfortunately, all the elements currently have default values, that is, zeros in the case of integer values. Thus, you need to set the values of particular elements. You can do this using the operator and an index of an element, as shown in this code snippet. Moreover, you can combine a declaration and initialization of array elements to specific values using one of the variants that we will enter. When you have the proper values of elements within an array, you can get values using the square bracket operator and by specifying the index, as shown in the following line of code. Here, you get a value of the third element, the index equal to 2, from the array named numbers and store it as a value of the middle variable. To summarize the information you have learned about single-dimensional arrays, let's take a look at a simple example, where the array is used to store names of months in English. Such names should be obtained automatically, not by hard-coding them in the code. Next, we will add related code snippet of the main method in program class. At the start, a new single-dimensional array is declared and initialized with default values. It contains 12 elements to store names of months in a year. Then the for loop is used to iterate through the numbers of all months, that is, from 1 to 12. For each of them, the date-time instance representing the first day in a particular month is created. The name of the month is obtained by calling the toString method on the datetime instance, passing the proper format of the date, MMMM, as well as specifying the culture. Then the name is stored in the array using the square brackets operator and an index of the element. It is worth noting that the index is equal to the current value of the month variable -1. Such subtraction is necessary because the first element in the array has an index equal to 0, not 1. The next interesting part of the code is the for each loop, which iterates through all elements of the array. Let's execute the program and look at the output. As you can see, for each of them, one line is shown in the console, namely the name of the month. As mentioned earlier, single-dimensional arrays are not the only available variant.